Dear learners, welcome back to SWAYAM NPTEL course on Library Automation and Networking. This is week 8, module number 8, Information Search and Retrieval, lecture number 40, and title of this particular lecture is Modern IR Applications such as Concept Map, Ontology, Data Mining, Semantic Web, Linked Data, and also Big Data. Dear learners, we have discussed much about information search as well as retrieval, as we know that it is one of the major components of any database where we need to have access to resources, and how do you search such kind of a databases and how do you retrieve the information in which are relevant for your requirements. So when you perform such kind of an activities, there are a lot of things to be done where we have learned about search techniques, search strategies, search tools, etc. And apart from that, retrieval, how this retrieval is possible, and that too in a relevant manner, like it should be very precise and it should have all the information which are required for you in a relevant sequence as well as ranking systems. So in this particular session, we will be discussing more about modern information retrieval systems, as we have seen that there are more information retrieval systems in the modern scenario like artificial intelligence, man-machine interface, natural language processing, which we have already learned. And apart from that, there are many other applications which can be implemented as modern IR applications. We will be learning about that, such as concept maps, ontology, data mining, semantic web, linked data, and big data. So dear learners, let's start from the concept of concept map. So what do you mean by concept maps in the information retrieval system? So when you talk about concepts map, it is like how we visually represent an information. So as we have seen that, suppose you are requiring for a particular article, you are just searching that and downloading it. So it may be like 5 to 6 or 10 pages. So sometimes we feel that if there is a graphical representation of such kind of matters which is already been discussed in that particular article, so it is easy for you to understand what this particular paragraph or particular article is talking about, because a small image can make such kind of a large or complex information in a very shorter format. So when we talk about concept maps, it is something like visualization of information which is available online, so that it is easy to understand for a user. Too much complexity of information will not be able to digest by a particular user. So once you prepare such kind of a information, complex information in a graphical or a visual representation, that can make some kind of ideas or concepts. So this, if you make it in a particular order, so that it is easy for any person to understand the entire concept of that particular article or the information. So in that way we call it as concept map is a graphical tool for organizing the information in a visual formats, so that the data or the knowledge can be represented in an effective manner. So when we talk about concept maps, so it has two components, one is concepts and the other one is relationship. So concepts normally we indicate in circles or in a boxes, and the relation will be made between the boxes. That means it will be connected with two boxes, or it can be connected with many boxes or circles. So the connection between the circles or the boxes, we call it as relationship. That means when you take an idea, that idea will be connected to other idea in a graphical representation, and this connecting symbol or the connecting link, we call it as relationship. In concept maps, the concepts are represented from a general to specific. That means the general concept or the general knowledge will be on the top, and from there it narrow down. That means it will be following a general to specific hierarchical arrangement or organization of knowledge or information. So concept maps basically for representing a complex information in an easy understandable format, in a hierarchical format, from general to specific, that too a visual representation method. It is a powerful tool for identifying relationship among the ideas. Let us look into this pictorial format of concept maps to make you more understand about the concept maps. This will be having a concept, and concepts sometimes will be having further classification like subconcepts, and subconcepts will be, or concepts will be associated with or divided, or it is categorized further as ideas. So in that way a concept map has three major components. One is nodes, that we have seen that the circles or the boxes in which it will be containing the idea or concepts or subconcepts. So the circle or even the boxes we call it as nodes. And the lines which are connected by two nodes, or we can say that circles or boxes, that we have seen that it is a relationship, it is called as links. So it will be normally represented by a verb or a phrase. And the third category is hierarchies. That means it won't be like specific to general, it will be normally from general to specific. So to make you more understand about a concept, it should start from a general idea. That means even if you ask any queries in a normal scenario, the situation should come in such a way that it should start from a general knowledge or general explanation. With that it will go down, that will make a very specific answer for that. Once you got a general idea, then it is easy for you to make understand about the concepts, the ideas in a narrow level. So here you can see a concepts map in the real scenario where we are talking about trees. So tree is a general concept. So we need to discuss further or narrow down the concepts in a concepts map. As we have discussed that we will be having nodes, we will be having circles and also the boxes, and that will be connected. That means the concept will be having subconcepts. Subconcept will be further divided into ideas. So these will be connected in a general to specific format. So when you take this particular example, tree as a general concepts, under that there are sub-concepts like oxygen, shade, paper. So as it is not having any meaning. As it is connected to tree as paper, that means there is a link or relationship between trees and papers, that is trees provide papers. This provide, we can say that it is a relationship. That means how the paper is related to tree, because tree provides paper. And further, when you look at oxygen, so tree also provides oxygen, and you further make that concept as an idea. So make a relation with that particular concept as oxygen, that means trees provide oxygen, or oxygen is needed by most of the living organisms. That means there is a needed, or there is a requirement by, or there is required by. So that needed by or required by, it is a kind of a verb or a phrase that we call it as relationship. That means from a general to specific. General trees, then oxygen, then it is a required for most of the living organisms. So this is the concepts map. So looking at this particular image, you will be able to understand what are the advantages, what are the provisions which are getting from a tree. So a complete long essay can be summarized and it can be visually represented so that it is easy for any person to make understand about a particular complex query. So this same thing can be applied in the information retrieval also, so that the retrieval process will be very much easy. Say for example, when you create a digital library, we will start from community, then sub-community, collection, and then the item or the material. So suppose if you wanted to make a university system, then under the universities there are faculties, under the faculties there are departments, under the departments you take a single department. So it comes from a general to specific, that if you visually represent, that will be very beneficial for you or easy for you to make understand about the concepts. This is what concept map says. So that will be easy for a person who is doing any kind of information retrieval at any scenarios. This is another example for concepts map, where you can see how ideas, concepts and basic concepts, and from general to specific it has been narrated in a visual representation format. So the benefits of concepts map in short is, it makes complex information easy to understand, and it also helps to memorize and recall the information which you gathered. That means while looking at a particular paragraph, that much recall or memory will not be there. But when you make an image or a visual representation, it is easy for you to memorize as well as recognize or recall it. And it also reveals the gap between the concepts or the ideas. So there will be sometimes there is a missing link. So it can foster your thinking also. That means you will be thinking about the missing things. So what are the other application, this particular tree and the oxygen concepts in between, what are the other steps or what are the other hierarchical ideas or even the boxes or notes can be made. So that will create some kind of a creative thinking as a user. It also improves the problem solving and definitely it makes the communication very effective. Dear learners, I hope that you got the idea of concepts map. Now we look into the next area, that is ontology. So what do you mean by ontology? Ontology is a set of concepts and categories in a subject area or domain that shows their properties and the relations between them. Say for example, when you take any musical instrument, say for example we are taking violin as an example. So when you talk about violin, so it is a musical instrument, so it is related to the domain music. And when we talk about what are the materials used in this particular violin, so you will be talking about a different thing. So that means the subject area will be different. So in that way the concepts or the domain specific conceptualization of such kind of a subjects, that means an informal conceptual system or conceptualizing the idea of that particular domain will be highly useful to get a proper idea or to get a clear understanding about the subject. So in that way it is an explicit formal specification of a shared conceptualization, defines the term used to describe and represent an area of knowledge. So it always brings a particular domain knowledge in one place so that it is easy for you to understand what are the concepts which are associated with this particular domain. It also provides a set of machine readable statements so that it is easy for you to make some kind of a effective information retrieval systems. So when you talk about ontology IR systems, it can retrieve data based on the similarity of semantics between the user queries and the index data. So dear learners, now let us look into an example of ontology. So when you look at this particular image, here there are two people, one is an old lady, other person is a veterinary surgeon. When a particular person like normal person who sees a particular animal, here it is represented as cat, so she or he will be looking at the external parts like how a cat looks like, what is the color of that particular cat and how long it is its tails, how fat it is, all these things. That means an external view of that particular cat will be looked by this particular lady. But whereas when you take a case of a veterinary surgeon, so he will be seeing all the anatomical structures of that particular cat. That means though the material is a particular item in which the views will be different or the angles of looking at that particular material will be in a different. So there will be always an ambiguity among the humans with the same materials. So what kind of requirement a particular person has, based on that, that has to be retrieved. So in an information retrieval system, if the lady looks for a cat, it should explain all about the physical nature, whereas a surgeon or a veterinary surgeon look at the cat, it should discuss about all the anatomical structures of a particular cat. So this is the difference in the domain. So we need to be very specific about what kind of information they are looking for, what is the domain specific concepts. So that should be retrieved. So it is very much having application in the information retrieval systems. Ontology can be top level ontology, domain ontology or task ontology, and also application ontology. So what are the advantages of ontology in terms of information retrieval? It exactly comprehend users' needs, users' information need, exactly understand documents' meanings, it can properly represent the knowledge, it has strong reasoning ability, and it can also integrate heterogeneous knowledge also. So dear learners, now look into the next concepts, that is data mining. So as we know that when we look at internet, so everywhere there is a data. So you can see that whenever you search something, you are getting a lot of information. That means though you have data, sometimes you are not able to get your own data. Sometimes you are having data but you can't use that. Sometimes you have data but that can't support your requirement. So how do we make such kind of a data, though which are available in a complex nature or in an unstructured format, how do we make it in a structured format? That we call it as data mining in a simple way. So data mining is a branch of data science. It is also called as knowledge discovery, KDD or knowledge discovery in data, knowledge extraction, data or pattern analysis, data archaeology, data dredging, information harvesting, and business intelligence. So in the real sense, when you talk about data mining, as we know that mining is something like you are digging. So when you go for a mining sector, so they are digging always and they get lot of, whatever the resources are available in that particular land. So even in the similar way, when you are going a mining process in a pool of data, that means it has a lot of data. From that, how do we extract useful data? So that process we call it as data mining. That means you will be having an unstructured or very complex and huge volume of data. From that raw data will be make some kind of a refining or filtration so that you will be getting a result or outcome that will be very much relevant for you. So you are extracting the complex data into a very specific data. That is very much useful. That means raw data into a useful information. That we call it as data mining. So a large stack of data from multiple sources will be gathered, and from there you will be filtering it, and then you will be getting a patterns that will be analyzed for patterns and relationships. That means even if we get different data, how it is connected, what is the relation, and how do we analyze it. So these all process will be part of data mining. So this will be always helpful in predictions as well as making smart decisions. So this particular filtration or segmentation or extraction can be done with the assistance of computers, automation tools, and a wide range of other technologies or techniques. So for examples of data mining, you will be understanding more if I tell about examples such as shopping market analysis, weather forecasting analysis, stock marketing analysis, and financial banking. So when we talk about weather forecasting, so as we know that what is the temperature today and what would be the temperature for another 1 week, and what will be the temperature after 1 month, and what is the growth and what is the declination, all these things will be coming to know because you have a huge data for today. So this data means a raw data that will be analyzed. That means yesterday it was temperature like this with that, and for the previous years, and all such kind of a data will be gathered together, and you can use some kind of an analytical technologies so that you will be able to get tomorrow's data. That means you are predicting that this could be the weather condition of tomorrow. So that is huge data will be mined and then will be extracted, and this can be used as a useful information. So we can see that here a large amount of data will be there. From that you are getting a useful data. In the other way, it is science, art, and technology of discovering large and complex bodies of data in order to discover useful patterns. So you are always making from a raw data to a meaningful data. Traditional information retrieval systems and data management systems can make such kind of data mining process, because if a particular person is always searching for a particular information, so with that data in which he is having a pattern can be made. Using that pattern there can be predictions and also decision making. So what are the different techniques in data mining, such as understand the goal first, then understand the data, prepare the data, model the data, evaluate the data, and deploy the solution. So these are the different steps which are there in the data mining process. These are the different techniques which are used in the data mining process, and apart from that there are different steps in data mining such as classification, clustering, regression, association rules, outer detection, sequential patterns, and also predictions and taking decisions also. So now learners, we will look into the semantic web concepts. So as we know that semantic means meaning, that means semantic web which is giving some kind of a meaningful information to you. Suppose when you are searching something in a Google and we search repeatedly for many days, and one or the other day the system will provide you, even if you type a single word or letter and system thinks that you are looking for this one. So it automatically makes all the list of resources or all the list of keywords in which one you wanted to select. That means the system is already identified your pattern and it knows that this is the thing you are going to make it, or this is the search you are going to make it now. So such kind of a meaningful searches can be made by a system that we call it as semantic web. So it is a vision about an extension of www which is already existing, which provides software programs. So when we define semantic web, it is a vision about an extension of existing www which provides software programs with machine interpretable metadata of the published information and the data. That means you are already having the data, so it is already there in the www, where we are giving some more meaningful platform or which will be having an extension for that, so that you will be able to access it in a easy method. So we often call semantic web as web 3.0, and as we know that it has the facility of interoperability where the information can be exchanged, and when we talk about information retrieval, the information from one platform need to be sometimes it should be compatible with the interoperability method, so that the information can be shared from one platform to the other platform. So that can be easily done using semantic web technologies. So the other way, it is an architecture for interconnected communities and also the vocabularies. So it is also a standard for interoperability that can facilitate knowledge exchange. So as we know that now the information or the knowledge which is available on the online platform, they are not just information. So they are linked with the other information, so where it will take you to from one platform to the other platform. So wherever you feel that this particular information should be associated with the other information, or all the information related to this particular concept should be retrieved, in such a manner this semantic web will be enabled to make such kind of a searches as well as retrieval in a meaningful way. So what are the advantages of semantic web in that way? So as we know that it will have many of the architectural structures, where from the traditional World Wide Web, so it is entirely different as it makes the system more dynamic, and it has many of the advantages when we compare to the traditional www. It is very easy to use, and here one of the major advantages is you will have a personalized area. That means the internet in which you are accessing become very much personalized, and online searches also will be personalized, and all your searches will be made easy as well as faster. So it replaces the existing read write web into read, write and execute. So easy to understand anything whichever is connected, because it has lot of hyperlinks and lot of connections and lot of interpretive operations. Easy to implement anything whatever is related to that, and of course sharing of knowledge is very much easier. It also helps in the network of information, especially in the online environment, and it also expands the connection with so many other data which are either related, structured or unstructured. and it also add a particular context to the data which is available on the web. So that means that data is not alone, or it is not a standalone where we will be having only that particular data. So that particular data will be associated with many of the concepts or ideas. Now let us look into the point of big data. As the name indicates, it is something big. That means the data is complex, where you will be having many of the resources at one place, either may be related or may be unrelated. So when the pool of such kind of informations are available as a big data, when the volume of such kind of data is increasing like anything, so you should have some kind of a mechanism where you should be able to dig out the information which are very much relevant for your purpose. So how do we do such kind of a data which is available in a big data, where that data can be useful for a very particular point of view? So as the nature, it is extremely large. It can be structured or unstructured, or sometimes the data will be in a semi-structured format. And as we know that that particular data will be continuously growing, so it is very difficult for you to make such kind of a complex data processed unless until we use some kind of a techniques or technologies. So normally when we talk about big data, it has major components, like we call it as 5 V's, such as volume, velocity, variety, veracity, and value. So when we talk about volume, that means big data. In the case of volume, it is the first V of big data, where volume is always in a huge mass. So it indicates the quantity of the data in which it is holding. So vast amount of data will be generated in every seconds, or that is the characteristics of big data. And the other one is velocity, in which measures the speed of the data and how fast the data is increasing or how fast it is growing. So based on that, we call it as the second V, that is velocity. And the other one is variety. As we know that when the data is increasing, the format of the data in which it is available in different formats, so that the formats of the data will also be parallelly increasing. The same information can be identified or can be received or can be available in different formats, say for example digital formats or even print format, CD format, or any other electronic formats. And the other one is veracity, where it talks about data uncertainty. That means we are not sure that today we have this particular data. Since the data is growing, so what will be the next data, or what will be the data in which comes in addition to this. So it is keep on changing. The nature of data is keep on changing. That we call it as veracity. And the last one is value. That means it has some kind of an economical value. Data has always have an economic value when you are able to make such kind of predictions or decision making out of that particular data by making some kind of an analytics. So that means using this particular huge mass of data, you are making it structured and you are making it complex to very specific, and you are taking some kind of a decision out of that particular data, looking at the pattern, looking at the growth, and as well as looking at the scenario in which how the growth is happening. So based on that, if you are able to make a good decision out of the data, so that will be an added advantage. So that is why we call it as the value of big data. So all these 5 V's are the characteristics of big data. And now let us look into the last area, that is linked data. As the data is linked, the name indicates that which is having an interconnection or which is having connected together, because many of the data, if it exists as alone, it does not have any other meaning. But when you look at the information retrieval system, where the data should be interconnected or data will be connected with other concepts, with that you will be able to make a complete scenario of that particular situation, that how this particular data is associated with other data. So it is a set of design principles for sharing machine readable interlinked data, and which is happening especially on the online format or in the web format. So it is a set of best practices for publishing your data, so that can be open to the public, so that we call it as linked open data, or LOD, where the data will be connected and the semantics or the meanings of the data will be connected to many other data or the concepts or ideas. So it is easy for you to get from one data all the related data which are associated with that if it is connected together in a meaningful way. So that we call it as linked data or linked open data. So when we talk about linked data, it should have some kind of a standard components, like it should have a link. So that link will be starting with HTTP, Hypertext Transfer Protocol, and there will be a HTTP's URI also. So there should be an unique identification for that particular material or the data in which it is available in the web. And it should also give some kind of a useful information. So you should be able to have a URL, URI, as well as there should be an information associated with that particular data. So normally that kind of a standards we call it as RDF or triplets. So when we talk about linked data or open linked data, as the data is connected each other and they are giving in a meaningful form, so it has its own advantages and disadvantages. When we talk about advantages, like it is work well for mass editing, multiple ways of describing the items, it can be edited, queried, etc., and more relevant resources will be more visible. So these are all the major advantages. Similarly, we have disadvantages also, like schemas, ontologies, and taxonomies, etc. They are sometimes inconsistent, and always it is a complicated matter in which data is in a huge format and they are related to many concepts. Organization also sometimes make the issues. So these are all the major disadvantages. So you can see the picture how the linked data is diagrammatically represented here. So normally linked open data will have some kind of a star system. So based on the license or based on the capacity of that open data, whether it is connected to interlink or whether it is having some kind of an interlink between huge mass of data, based on that star levels will be there, and each star will have its own meanings. So this is the simplified example of such kind of a linked open data. So dear learners, with this let me conclude this particular area. So we have seen that how the modern information retrieval applications are available: artificial intelligence, natural language processing, man-machine interfaces, ontologies, semantic web, data, big data, linked data, or open linked data. So these are all the major applications which can be highly impacted on information retrieval systems. So as a person who is working in a library and information center, you should be able to make use of such recent technologies or the techniques for the benefit of users in retrieving the relevant information in an effective and efficient manner. All such kind of technologies will give you an experience of having such kind of refined information from a pool of information. Thank you.